simple. We input an A followed by a C. We pattern match for a block from A all the way up to C, and then once we found that block, we replace the block with a single asterisk. And that is done in by breaking the input down into three different pieces: the front, the block, and the tail. For this first example, we have a grammar which is very simple. It just says it has two rules, main and rule A. Main just calls rule A. Rule A pattern matches for a single lowercase a. Once that's found, it starts up the reformatter, which is this stuff down here, the glue file. And the glue file contains the same rules with the same names as in the grammar. So whenever a main is matched, it calls this rule here. That rule says I need to find the value of the rule A and bind it to this parameter. So then it calls the rule A. Rule A gets as its input a single character, which was pattern matched by the pattern matcher. So that little c gets filled in with an actual value of a little a, and then we use JavaScript template string syntax to return the value that was matched, which in this case will evaluate to a string with an a in it. That gets returned to here, to this parameter. This parameter then gets thrown away, and we return a string containing only a single character star in it. Really simple. We start with an input of A followed by a B followed by a C. We look for a block which contains an A and a B and stops at C. When we find that block, we replace it with a single asterisk. Again, we just break this down into three pieces and then work on it. The second test is almost as simple as the first. We have, again, only two rules, main and rule A. The difference here is that rule A matches for an A followed by a B instead of just an A. When all that's been matched, we then invoke these two rules down here. First, we come down to this rule. It passes the string that was matched, AB, which I called 2C, and then we return that value of 2C back up the tree to here. From here, we again throw away the result and replace whatever was matched by a star. For the third test, we reuse the test2 grammar and test2 glue files, read-write files, and we use a different input. This is ABC followed by ABC. And here we're looking for blocks of AB stopping at C. There's one block and then another block. Once we find those blocks, the first time through we find the block and we replace the AB with a star. And then we rematch. We find another AB down here stopping at the C. And we replace that with a star. And then we get a final result, which is star C, star C. Again, as I said earlier, we reuse the test2.ohm and the test2.glue files. We invoke it the same way, but we give it a slightly different input, test3. To reiterate, the invocation of test3 says call prep, look for an AB, and then finish the block whenever you see a C. And when you find a block like that, so AB goes into pattern matching of test2.ohm, and once it's been pattern matched, it goes to test2.glue, and then it repeats the process as many times as necessary until it has nothing left to do, and then it gives the result. It is very similar to test 3, which is very similar to test 2. The main difference is that we input something slightly different and the command line is slightly different. And in the end, we're pattern matching AB, replace it with a star, then we look for another AB, replaced by a star, then we look for another AB and replace it with a star, and in the end, we come up with star, 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 C. And here's the command line for test 4. We start a block when we see an AB, we stop a block when we see the next AB or a C, and then we get the input from test 4. We run a much longer string containing new lines in it through the tester, and we change the command line to pattern match from the beginning to the end. And whatever we match, the whole thing gets replaced by a string that says less than, elided, greater than. For this fifth test, we have a multi-line input, hello world, third line, empty, a new line with an empty line in it. We have a pattern match that says call rule any one or more times. Rule any accepts any one character, but because it's being called up here, it gets called over and over and over again, one or more times. Once the pattern matching is finished, we go down here and we replace, as before, here we use the @ syntax saying that we got a tree of more than one possibility coming in, and we throw all of that away and replace it by this string elided. Do something more interesting. We take a big long chunk of text and we look for a block that starts with any number, one or more octothorpes, followed by the keyword forall, and we pattern match, we create a block up to the next octothorpe, and we then process this block through the grammar and the reformatter. We find a block, a forall block, we pass it into this grammar. The grammar starts at the main rule, which says a legal version of this block must have one or more sharps. I didn't want to type the word octothorpe there. Then followed by a literal string for all, then followed by an ident, which is defined lower down, then followed by a literal string AS, then followed by a call to a predicate. For some reason I put a white space, 0 or more white spaces, 0 or more new lines, an ident, an equals string, a string with a cond in it, and then one or more conned clauses. If we go down and look at the various rules down here, you'll see how these are all defined. Once it's been pattern matched, each one of these rules supplies the part that it matched to the rewriting, the reformatting part in the glue rules. After we've finished pattern matching, the pattern matcher actually produces a tree, and we walk the tree. We go down and then we come back up, and here we see a little bit more complicated glue rule that handles the down and up business. Going down, we can enclose any kind of JavaScript code here in double braces, and coming back up we do what we've already seen, which is enclose a piece of JavaScript text creating code in double brackets. In this particular case, I call a function called in support called push ident, and at this point the variable name ident2, which corresponds to this thing up over here, this part of the tree match here, is actually called _ident2 at this point. This is probably going to be simplified, but at the moment I'm experimenting with ways to expose this stuff to JavaScript. And then to do the downward tree walk, we say dot underscore glue function call. And if it returns only one thing, then we call that. If it returns more than one thing, we also dot join. We call dot join on the result. The point of this code is that we want to take the forall chunk and rewrite it as a number query chunk. We start by setting up a fresh identifier as we walk down the tree, and then as we come back up the tree, we start sending strings back up the tree, and then we combine the final set of strings here, and we just in this code, what it does, it just takes literally what was given to us in the sharps, joins them together because the @ sign. It then puts the literal string space query new line out as part of the string. Then it dials up the value of the predicate parameter or the predicate part of the tree that came from down here. There's predicate there. And then it puts parentheses around it and does it inserts the value of the conned clauses and any conned else, and then wraps parentheses around that. So what actually happens here, let's take a look at the rule predicate. So in predicate, if we go back to the grammar up here, predicate says it's got to have an identifier followed by an open parenthesis followed by a subtree of actuals, then followed by a closed parenthesis, then followed by white space, 0 or more white space characters. I'll stop for a moment. So when we match a predicate, we get an identifier, which gets parsed down here. It's a first character followed by a bunch of other characters. It gets glued together into a single string that gets returned back up here. Then we get the constant k left parenthesis. Then we get we call something called actuals, which is down here. We also get something which is a constant right parenthesis, and then we get 0 or more white space characters. I'm not even sure. I grew this stuff while I was testing, and I obviously was writing lexical rules at the beginning, and then I switched to using predicate is a lexical rule, so it will try to match character by character without skipping white spaces. So I had to stick in a white space catcher, and then when it gets all this stuff and it's coming back up, then we glue together a string that consists of the identifier followed by the open parenthesis followed by whatever the actual string is, followed by a closed parenthesis followed by a space, and nothing else. We threw away the white space, and that's about it. And then we return it back up here into predicate, up to here predicate, which ends up in this part of the string, and then we glue it all together and we get a final string, which is all the stuff we didn't touch plus the stuff we did touch, which is the forall block. We replace the forall block by a bunch of code that starts with the number sign query. The command that kicks all of this stuff off says look for a block that starts with one or more number signs followed by a forall. The block ends on the next number sign, set of number signs followed by a space. When we find that block, we then hand it to the forall pattern match in grammar, After the grammar, we hand it to the reformatter, which is written in the forall spec, which we just discussed. And then we input from the test forall input file. And we there's a new line here. Well, the text editor has folded this. So that actually says minus support equals some directory that's defined elsewhere in the shell script and calls support.js. .js, I've got it in an editor here, is pretty simple. It just exports two things, push ident and get ident, both of which are functions. It keeps an internal ident stack but does not export it. And when we call push ident, it's a function that takes a string and it pushes that string onto the ident stack. In a moment we'll see what that does. If we look at the source code of the test forall text, then we see the block that we're working on is this block here. There we go. Got it. And so it'll say the pattern matcher will try to pattern match that, and then it'll match this as the ident that we saw in the previous thing. Then it sees the keyword as, and then it sees a prologue clause, and then it will process these other clauses all the way to an else. This syntax is that so once we get into the forall, we want to set up a variable called direction, and we want to do it on a condition. And the condition is, if this is true, then we want the direction to be the word input. Otherwise we try this, it's output. Otherwise we try that, it's pervasive input, pervasive output. And if all of those fail, then it becomes the question mark. And then later on we test the question mark and then fail if we see a question mark in here. I've run into the situation where I've written a whole pile of markdown-ish queries against a fact base and in prologue style. But what happens is that the query silently fails due to the way prologue works if any of the query clauses are false. What I really wanted was to say, if you match the first clause, then all the other clauses must be true. And what we're going to do here is produce an implicit for all on all the existing code, wrap it in that, and then pump it up. The rule for matching implicit for alls consists of basically one line of interesting code. The rest of it is just helper stuff. And it's broken up into three rough pieces. There's the header, the first rule, and then the rest of the rules. Here we see an interesting pattern matching trick. We match the same pattern from two different places. This is essentially a no-op at the grammar level, but at the reformatting level we will want to know whether it came from here or from here. Here's the pattern matching trick again. Here are the two rules that match the same kind of thing, and you'll see that the output is different for each case. What we want to accomplish here is to match the incoming code and then format the first, just dump the first one that we see, first clause that we see as is, but the rest of the clauses get dumped with an error message wrapped around them. And that's what this reformatting does. And here's the way we invoke that command. We call it prep. The start, look for a start that has numbers followed by a space followed by query, ends with the next number sign, numbers with a space. We then call implicitforall.ohm, and then we pass the result to implicit.forall.glue. We have a support file here. There we go. And from there to there, that's the support file. The input comes from this test file, and in this particular case, we dump the output into something called a file called temp.